Today we are going to see the third unit, in that how to find out the global stiffness matrix in the triangular element. This is the global stiffness matrix formula. The K denotes global stiffness. B transpose, the B is the strain displacement matrix, and D is the stress strain relationship matrix. A is the area in mm square and T is the thickness in mm. Now we will see one problem, that constant strain triangle element, that is a triangular element. In that, how to find out the stiffness matrix. This is the problem element. Evaluate this element stiffness matrix for the triangular element. Find under the plane stress condition. Plane stress condition, and E is equal to 2 into 10 to the power of 5 Newton per millimeter square. Poisson ratio is equal to 0.3 and T is equal to 10. Plane stress condition is useful to convert the 3 dimension into 2 dimension. That is, we will consider it as a very small thickness it has. If any plate or any problem, very small thickness, in that we consider the stresses in the sigma z tau of xi tau of y is all or 0. In that condition, the problem, 3-dimensional problem, becomes 2-dimensional. So we are going to consider this triangle element as a 2-dimension and find out the stiffness matrix of that. Here doesn't it plays huge role? I'll tell you in the next problem. 0 0, this is 3 0, 1.5. These are the coordinates. You have to mark the nodes in the triangle. That's I will mark here 1, 2 and 3 in anti-clockwise. In anti-clockwise you mark the node 1, 2, 3. Then find out the coordinates x1, y1, x2, y2, x3, y3. So I have written all the given data. So these are the coordinates points that has been given in the triangle. Now we have to find out the element stiffness matrix. K is equal to B transpose D B A into T. This is the area of the element, T is the thickness, and B is the strain displacement matrix and stress strain. Now we will find out what is the area. We are going to find out the area. This is the formula: x1 y1 half into x2 y2 half into x3 half x3 y3, that is not u3 y3. So I substituted x1 value, x2 value, x3 value, in that problem it is coordinate values, and I'm finding out the determinants of this value, and I'm getting area is equal to 6 mm square. The next step is to find out the strain displacement matrix. That is the formula: B is equal to 1 by 2a q1 0 q2 0 3 0 0 or 1 0 R3 R1 Q1 Q2 R2 Q2. This are all the formula. You have to mark it to memorize this. This area 2a is the area. Q's are the y coordinates and R are the x coordinates. Q's are the y coordinates and R are the x coordinates. So Q is y2 minus y3, Q3 is y3 minus y1. So see here, you take like this, in this way, 1 2 3. So see, now this is Q. First you are going to find out Q1. So keep this one and look here, Q2 minus Q3. Now if you want to find out Q2, keep this here, Q3 minus Q1. So now we want to find out Q3 you have to find out, keep this here and look at Q1 minus Q2. So U1 minus Y1 minus. So in that way, again I will tell you, if you want to find out the Q1, keep this force, don't forget this force, remaining 2 3. So Y2 minus Y3. And 2, when you want to find out Q2, keep this force, 3 minus 1, y3 minus 1. In that way we have to find out, and the x coordinate will be exactly opposite to the y coordinate. See, y2 minus y3, x2 minus x2, y3 minus y1, x1 minus y3, x1 minus s, in the x2 minus, lastly you see y1 minus y2, x2. So exactly opposite to this. So easily you can make it up in this format if you have. So easily that values I have written from y2 minus y3 x, they all given in the triangle. So I have written this. Substituting, on substituting, I am getting these values should be substituted here. So these values are substituted, and I got this area into 2 1 by 12 it will get. I got this. Here the plane stress problem. So the strain displacement matrix will be this formula, but if it is a plane strain problem, this formula will get differs. So please look into the problem. If they ask plane stress, and use this formula for strain displacement matrix. So in the stress strain relationship matrix, sorry, D is equal to stress strain relationship matrix. So in that way, for plane stress it differs. Plane stress another form, plane strain another form. So substitute, this is Poisson ratio. We have the Poisson ratio, that is mu. That value I have substituted, it is given in the problem, you don't want to find it. So I got this value. Now D I got, B I got. Now according to the formula, we have to keep B transpose D, B D. So first I'll multiply the DB. So D matrix and B matrix are written. This is D matrix, this is B matrix. Both should be multiplied. How will you multiply? This value, this value. 1 into minus 4, minus 3 into 0, 0 into minus 1, plus அடுத்தது 1, this and this and this way, again this matrix into this matrix into this. So my matrix multiplications, you know very well. On this multiplications you get this value. So you this value you got dB. So now what stiffness matrix formula is, what stiffness matrix B transpose I have to find out. So writing the B's over here, writing the B and taking the transpose of this. I took the transpose. Now I am going to multiply the B transpose with this B transpose dB. So now I have written the B transpose. Don't change the order, then you cannot multiply at all. Okay, never. B transpose should be written first, then dB, and this again multiplication. I got this value. I got this completely. This and this and this and this are multiplied. This and this. 1 by 12 into 18.32 gives you this much. This much, and this multiplied, you get this much. So this value, this is 6 by 6 matrix. You will get 6 by 6 matrix because in triangular there are two nodes, isn't it? Two nodes, because it's a two-dimensional, 2 degrees of freedom. So there will be a, if 2 degrees, according to the how many nodes are there, how many size of the matrix can be decided. So 6 nodes and 6 by 6 matrix. So 6 by 6 matrix is given. So now this matrix should be multiplied by area into thickness. This is the value area. Area is 10 and 6. So I have multiplied this value into area into thickness, and this I got this. So this is the global stiffness matrix. Only thing you have to hear, this is a plane stress problem or plane strain problem, and whether it is given in millimeters or meters. If you in this meters, limits convert that into millimeters. And order, the order should be B transpose dB, first multiplied by this 2 and then multiplied by this. And while writing B transpose must be written first and dB should be written second, and then you have, it should not be dB first and then come, it will be completely, it will be wrong. So in this way you have to multiply. This is the global stiffness matrix for the two-dimensional triangular element for the plane stress condition. Thank you.